For this problem, our goal is to graph a piecewise function, and we've got three pieces here to consider. As we consider our first piece, where the function will equal -1 when the function has x values that are less than or equal to -1. Well, let's consider what the graph of essentially y equals -1 looks like. Y equals -1 would be a horizontal line passing through the y-axis at -1. So you can see how a portion of our resulting graph here falls along that line. And the portion that falls along that line is the piece where all of the x's are less than or equal to -1. At this point right here, this is the point where x would be -1 on that line. If we're talking about all the values that are less than -1, we'd be talking about all the values out here to the left, so that's why we graph only this portion of that line for this piece of the piecewise function. So we move on to the second piece, where basically we're considering the graph of y equals 3x plus 2. If we were to graph y equals 3x plus 2, we'd start with a y-intercept at 2, and then we'd utilize our slope of 3 and count up 1, 2, 3 places and 1 to the right to get our next point. Now if we drew that line would pass through the 2 points we found here. The reason we've only included the piece that you see here between this point and this point is because at this point x is -1, and at this point x is 1, and our domain for this portion of the graph tells us that we only want to graph this piece for this function 3x plus 2 between -1 and 1. So that's why we only have that part of the line in between those 2 points. As we consider our final piece here, where basically we want to look at the graph y equals 7 minus 2x, well, we'd start in graphing that by going up on the y-axis to where y is 7, so we'd have to go up here a little higher than the actual graph. And then we would utilize our slope of -2 and go down 2 places and 1 to the right to get our other point. We'd get a line that essentially goes down this direction, and we'd graph the piece of that line where all of our x values are greater than or equal to 1. So at this point right here is where x is equal to 1. We want everything that is greater than 1, so we want the portion of the line that is to the right of that point. So that is how we come up with our graph for this piecewise function. Now as we go down here and consider our domain, which is another thing we're asking about on this question, well, our domain of this function g as it's defined is going to be all real numbers. And one way to consider that is to look at the resulting graph, and as you go from left to right, you will notice that all x values are included as we go from left to right. So that's one reason why the domain would be all real numbers. The other reason comes from piecing together our 3 pieces here and considering the domain part. We've got all values of x up until we get to -1 and including -1 here. Then we pick up at -1 and continue on to 1 here, not including 1. But we get to this final piece where we do include 1, and then we continue on to the right. So every x value is being considered here for this piecewise function.